we want to calculate a binomial expansion with the help of Pascal's triangle. I know that you have already the binomial theorem for that, but we want to focus on this characteristic of the Pascal's triangle. And we've chosen a pretty easy example. It's x plus 2 to the power of 2. And as a starter, we have to identify what power do we have in this case. In this case, of course, we have power n equal to 2, because everything is squared, is elevated to the power of 2. What does this tell us? This tells us that we need the nth plus 1 row to calculate the expansion of the, so on the power is only equal to 2, we need the 2 plus 1 row of the Pascal's triangle to calculate the coefficients. So we're gonna take row n plus 1, which is of course 3. So we need the third row to calculate the expansion of this binomial. Alright, so the third row of the Pascal's triangle is here. We have the elements 1 to 1. And let us write them here as a reminder. The next step to calculate the expansion of this binomial is to calculate which term is going to show up in the polynomial once we have expanded it. And the term can be easily calculated by multiplying the two terms of the binomial. So x multiplied with 2. And I know you are tempted to write this as 2x, of course, which is not wrong. But for this exercise, bear with me. We're going to keep them separated because we need to reason a bit on the powers which each term is going to get. So, alright, let us calculate the first term of the expansion. We take the first element of the third row of Pascal's triangle, which is going to multiply the coefficients. So 1, which multiplies the term we calculated here, x and 2. Now we have to assign exponents to both x and 2. It is a bit of a rule that the first term is going to get the highest exponent available, while the other is going to have the lowest instead. So we have everything to the power of 2, the binomials to the power of 2, so x is going to be to the power of 2. And the least exponent in this case is 0, so we assign that for 2. Alright, this is the first term. We're gonna do simplifications in the next steps. First we want to write what calculations are we performing. So, plus, we must take the second element of the row, in this case 2. So we write 2, which multiplies x multiplied with 2. The exponent for x diminishes by 1, becomes gradually less and less, while the exponent for 2 is gonna instead increase. So if we have x to the power of 2 here, we're gonna have x to the power of 1 here. You see? The exponent has been reduced from 2 to 1. Here we had in the first element 2 to the power of 0. 0 is gonna increase instead. So 2 to the power of 1 here. Alright, we have just the last element to calculate, so plus. The last element of the row is again 1, so 1, which multiplies x must decrease yet again. So here we have x to the power of 1, here we're going to have x to the power of 0, which multiplies 2 to the power of 2. Here we have 2 to the power of 1, so we have to increase to the power of 2. Now we just have some simple simplifications to perform. I suggest starting from the powers. So I'm going to copy 1, which multiplies x to the power of 2, cannot be written in any other way, so we just copy that, which multiplies. What is 2 to the power of 0? We have to remember that any number to the power of 0 is equal to 1. So we can just write times 1 in this case, plus 2, which multiplies x to the power of 1. Here we have to remember a number, a term to the power of 1 can be written as itself without the power 1. Something pretty simple. So I'm going to just write x here. X to the power of 1 and x are the same thing. And of course, same logic for 2 to the power of 1. We're just going to write 2 in this case, so multiplied by 2. Alright, so last term is 1, which multiplies x to the power of 0. Again, same logic. If something is to the power of 0, we can just write 1. 2 to the power of 2 means 2 times 2, which is pretty simple. It's 4, of course. Okay, we are only left with some easy multiplications. Let's do them. So 1 to the power of x to the power of 2, 1 times x to the power of 2 is of course x to the power of 2, multiplied with 1 is again x to the power of 2. So nothing too complicated, I hope. Plus 2 times x is 2x, times 2 becomes 4x. Or you can just imagine to just multiply the coefficients first, and the variable is going to just tag along. So 4x plus 1 times 4, okay, nothing too complicated, we know that it's just 4. And alright, we have the binomial expansion, and as I said, you could have used the binomial theorem, you could have reached this result the same way. But we have used instead Pascal's triangle. It was just a warm-up to see how we can use this triangle to solve this kind of exercises.